Oumuamua was the first visitor from an alien world, and now it slowly disappears again from the solar system at its current position, far behind Neptune. It's no longer visible to our telescopes. Will we now never know what Oumuamua really is? Or will the object possibly return? Join us now as we share the latest findings surrounding this event of the century. The mystery of Oumuamua. It doesn't happen every day. In 2017, the Pan-STARRS Space Telescope in Hawaii sighted an object that no one had ever seen before. Oumuamua was initially thought to be an asteroid that narrowly missed Earth. Then it quickly became clear that this object had come to us from interstellar space, making it the first craft of its kind. For 11 days, the alien kept the world of science on tenterhooks. Then Oumuamua moved away at breakneck speed, without researchers really managing to unravel its mystery. Now Oumuamua is gone. It has passed beyond Neptune's orbit and is so far away that no telescope will ever be able to study it again. Oumuamua emits no light at all and also reflects light very poorly, making the object hard to spot at this distance. Because of its small size of just under 1,000 meters, its strange shape, and its furious speed, even our best telescopes cannot detect the stranger so far out in space. The last investigations had shown that the new orbit will carry the strangest celestial body of all time directly in the direction of the constellation Pegasus. Or Oumuamua will hit a snag and come back again. Such an unusual, and for an ordinary asteroid or comet, completely impossible maneuver. Oumuamua had already shown once, shortly after it had passed the Sun. Oumuamua first braked, then turned in a sharp angle, accelerated, and came back towards us. This strange behavior cannot be explained. Until today, the origin of the object and its true nature remain a scientific question, around which a fierce dispute has broken out. Is Oumuamua a fragment of a celestial body, such as a planet or a moon, that was hurled towards us from a distant star system? Or is it a piece of alien technology that was sent to our solar system, either accidentally or intentionally? Scientists found plausible explanations for both theories, and we'll look at them now. Not an asteroid and not a comet. Oumuamua has unusual nature, makes it impossible to classify the object unambiguously as a comet, an asteroid, or anything artificial. However, it would be important to know what this piece was. Among other things, 6 new objects that allegedly have similarities with Oumuamua should provide information. Among the most extraordinary capabilities of the unknown is undoubtedly its unusual ability to accelerate. Asteroids and comets accelerate through chemical processes or the interaction of gravitational forces in space. The acceleration, RATES, can be explained and understood with the formulas of physics, but not so with Oumuamua. Information about the true nature of Oumuamua could be provided by a completely new category of celestial bodies called dark comets. Facts about Oumuamua. For all of you who don't know Oumuamua yet, we now share the most important facts again. Oumuamua was initially named a /2017 Yuan, or C/2017 Yuan Pan-STARRS. The object was discovered on October 19, 2017, by the Haleakala Observatory in Hawaii. The Pan-STARRS project uses the telescope to protect Earth from asteroids. After it was clear that the object came to us from interstellar space, it was then given the name 1/0 Oumuamua. The 1 and / combination stand for the first recognized interstellar object to enter our solar system, and Oumuamua means first scout from an alien world. The size between 100 and 1,000 meters fit first to an asteroid. The form, however, not so much. Sometimes it appeared as an elongated cigar, then more like a flat disc. Its trajectory and speed made it clear that this object was different from anything that had come before. Probably in truth, Oumuamua is not the first interstellar object to speed through our solar system, as there are potentially billions of possible objects that also did the same thing. It's just that we humans didn't notice these objects in the past, or we simply did not have the technology necessary to do so. Even normal asteroids are extremely difficult to spot, as they do not emit any light themselves, and depending on the material, can absorb all the light that hits them. Comets, on the other hand, are usually brightly glowing objects that can often be seen with the naked eye from Earth when they are in a near-Earth orbit. When Oumuamua was discovered, It had already sped past Earth and was about level with the Sun. Then Oumuamua suddenly accelerated by about 17 meters per second. It seems small, but this kind of acceleration violates all known laws of physics. In any case, it was enough to cause a stir in the world of science. In physics, objects can only accelerate and change their trajectory as drastically as the Oumuamua did when pushed. And so scientists began to seek explanations for the pushing force. Some initial hypotheses that solar winds pushed the object were quickly discarded. The force exerted by solar particles is not enough to explain Oumuamua's acceleration, assuming it was some kind of rock. Even the best photos of Oumuamua showed only a tiny speck, giving little indication of what the object is really made of or what it looks like. Most theories about its shape came from the variations in its light curve, whose brightness rose and fell uniformly as Oumuamua traveled around the Sun. The results were absolutely not in favor of a round object, but rather showed alternating evidence for an irregularly shaped object, such as a disc or a cigar. Dispute about Oumuamua. Scientists searched strenuously for comparable examples of accelerating objects in our solar system and came up with comets. As comets approach the Sun, the ice within them heats up, sublimates turns to gas, and sputters out of the comet's main body. This ejection of gas and dust forms the comet's characteristic tail and gives the comet a small thrust, acting like a small thruster on the side closest to the Sun. Comets are thus accelerated away from the heat source. Around Oumuamua, however, no evaporation, such as ice, dust, and gas, could be seen. These evaporations would have also made Oumuamua more visible. The absence of this similarity to known objects led to more exotic theories. The first theory came from Harvard professor Avi Loeb. Loeb was the first to proclaim Oumuamua could represent extraterrestrial technology. He argued in 2018 that solar winds could provide the acceleration observed at Oumuamua, but only if it was actually much thinner than scientists originally assumed. By thin, Loeb suggests somewhere between 0.3 and 0.9 millimeters thin. Since a 1,000 meter long, 1 millimeter thin object is unlikely in nature, Loeb argued that it must be artificial. A light cell created to capture solar winds and use them to accelerate from one star to another. This theory met resistance from other members of the academic community. Daryl Seligman, a theorist and postdoctoral researcher at Cornell University, countered in 2020 with a study that found that perhaps no outgassing of Oumuamua was detected. Because it was emitting an invisible gas like hydrogen, this would not have been detectable with telescopes pointed at Oumuamua. Seligman suggested that Oumuamua was composed entirely or mostly of such hydrogen, a hydrogen iceberg that sublimated thanks to the Sun's heat, and the sublimation produced the thrust. Loeb and Seligman got into an argument. A few months later, Loeb published another paper challenging the other theory and asking where exactly this hydrogen iceberg could have come from. He showed mathematically that starlight in interstellar space is warm enough to melt any hydrogen iceberg that would have formed in the nearest dense molecular cloud before it came anywhere near our solar system. Loeb was still convinced that an extraterrestrial technology explanation was most likely. Seligman revised his hydrogen iceberg theory, but maintained that Oumuamua had been moved by escaping pure hydrogen gas. Seligman eventually found support from Jennifer Bergner in 2023. The assistant professor at the University of California found evidence in the laboratory that his hydrogen thrust theory was correct. The two wrote a paper arguing that Oumuamua was a whole new category of celestial object, a quote-unquote dark comet. Their new explanation took into account Oumuamua's acceleration and also its lack of dust, since dark comets need not emit dust. These objects create their propulsion by reconfiguring hydrogen structures inside. Avi Loeb was not convinced and wrote 2 new papers on the subject himself, accusing Seligman of bad mathematics and continuing to push his extraterrestrial spaceship model. Seligman was then already busy searching for proof of his theories and looking for clues to other dark comets. Together with Bergner and some other comrades in arms, he combed through data of objects that had already been registered in our solar system but could not be explained. 6 dark comets. In fact, the research team found 6 objects that fit the criteria, -1 objects that showed non-gravitational, non-solar wind acceleration that could not be explained by any known mechanism. These objects were small. Some measure as little as 3 meters. They looked like asteroids or near-Earth objects and showed no special features except for the strange acceleration. Until now, these accelerations had not been noticed because the rates were very small due to the small size of the objects, and the strange behavior was not noticed at all. It wasn't until Seligman and his colleagues specifically looked for these rates that the candidates stood out. These objects do not flit from planet to planet through the solar system like Oumuamua. They are also not interstellar objects, but they resemble Oumuamua and could allow conclusions about its true nature. In 2031, the Japanese probe is expected to study these strange near-Earth objects and even collect some of them and bring them to Earth to study. Perhaps then, Seligman can look forward to a late triumph. But for that long, you will be no more able to prove his theory than Lo. With Oumuamua now far beyond our reach, we may never know. All attempts to quickly construct a probe that could still catch up with Oumuamua failed, of course. It could end up that neither theory is correct. The longer and deeper we explore the universe, the more we encounter strange and unexpected phenomena, and the more we will learn. Maybe one day, more objects like Oumuamua will appear in our solar system, and we will find a conclusive explanation for the phenomenon. But what do you think about this dispute among scientists? And do you have any idea or explanation for what Oumuamua really was?
Subscribe to my channel. Subscribe to my channel. Subscribe to my channel. Subscribe to